Okay, so for today I was thinking to start a small project on the cool programming language. And I wanted to do this just to create a compiler for it. And yeah, because not really because it's a nice language to use, but more because it would be fun to understand how the programming languages work basically. So this programming language, we can look in the manual of it, is really similar to Java, meaning that it has classes and inheritance. But I think the resemblance to Java like stops there, and then it, in my opinion, it starts to be a bit like Rust in some way with the lets and switches. It has some pattern matching, but it's not really that great. But yeah, I mean, I feel like it is a combination between like Java and a bit of Rust, let's say. So yeah, I mean, the first thing that I think we can try to do is to use I mean, it's called the reference compiler basically, and we can use it to like understand how to write some of this code and try to create, I mean, a hello world, maybe a list or something, and after that we can try to build a tokenizer. And I was thinking that the language to use to implement the compiler should be C, because it's like really straightforward. You don't have any complex um, stuff. You need to just have structures and functions. So we are not gonna get stuck into, let's call it, analysis paralysis and try to come up with algorithms or like weird OOP for the compiler. Will just have for loops, and pretty much that's it. We're gonna iterate over the tokens. So yeah, let's try to see in the code now. I've already made like pretty much just a make file and some tests, which I just copy pasted them, and they are like snippets of cool. And reference, I have to change the reference because it's not made for tokenizer. So yeah, basically the compiler is also downloaded it from here. So you just take this one and you have the compiler, and the checker just runs the compiler, like your compiler, on the test, and it compares the results with the reference. Anyway, so let's try to create a main.cl file. Yeah, the extension for cool is cl, and yeah, for new Vim, actually you can find cool Vim syntax. You can actually find well, I'll yeah, I think it was this one. So yeah, I'll be honest, I had no idea how to install it. I just put it inside of syntax and it picked it up automatically. Maybe, yeah, that's how it works in new Vim, but sure, whatever. It's from Vim scripts, cool.vim. Anyway, so first let's try to start with the hello world, and I guess as in Java, we need the main class. So main. Okay, so after that, like the easiest way to do it, I guess this is a bit of jumping around, but basically we have some basic classes in this language, and each class comes with a functionality. And the most important one I would say is IO for us right now. And basically this function gives us like a way to interact with the console. Basically, like we can print with outstring. So yeah, like the easiest way to have that, like to have those methods inside of main, is to just inherit IO, right? After that, let's see how we do methods. Oh, so yeah, methods are here. So basically methods are just the function name. So we need a main function, right? So main, then the parentheses, what it returns, I guess. So it returns IO, right? And then the body. And then we can call to out string hello world without the, and yeah, basically another thing about this language, which reminds me a bit of Rust, is that all the expressions and stuff have like return values. So if you call to out string, I think if we go back to IO, you can see that out string returns this self type, which is basically like IO, right? I think. So if you call this function and you don't put a semicolon, then it will return its type, or like, you know, return the thing. So if main is IO, then this is just like calling return, but we don't have a return keyword. Anyway, we need to add the semicolons after each method declaration and after each class declaration. That's the part that's a bit sad about. So we can call cool on tests main, and as you can see, we get the hello world. I can increase the font, but I think it's large enough. Yeah, we get the hello world. So the next thing that I wanted to try, just to play a bit around with more complex code, is to implement like a list. And let's try to make it inherit again from IO, just to make things simple. So basically this list will have a head, which will be a string, and it will also have, like, the head is basically the value, we can call it value, and it will also have a next, which is a list. Okay, so yeah, the next thing would be a new function, which will take in a value and the next element, and it should return us the list. Right, we initialize. I mean, I think that's how at least that's how methods, I thought they work. The ID, the list of stuff. I mean, I'm not sure why it's with red. Maybe we'll figure it out. Maybe it will give us an error. So after new, let's try to create a print, which is an IO, and yeah, basically here we want to outstring value, and let's use another function from our like basic classes, which is for string, and that's called concat. And concat allows you to append like another string to our current string. So we can do something like append, well, it's concat, and let's put a space. Okay, and after that we have to check if next is void or not. So basically, if is void next, I think that's how you do it. Then we just print a new line, and otherwise we print the next element. And yeah, we don't have curly braces for if statements. We have then, else, and phi. So yeah. Okay. So then let's change this thing with a let, and basically we can initialize the list like this, and then we can use in statement. So let in, similar to like, I don't know, in Haskell or something, we can do something like L print. I think that should be enough. So it doesn't like this thing. Well, yeah, obviously it doesn't like it because it's a keyword, right? So we have to use something like maybe it. On line 6 it says, we have to use the arrow operator to initialize stuff. And we also have to use blocks in the thing. And here, semicolon. And here we also need to use blocks. What, like this maybe? That's fine, I guess. Then on line 21, do we need a semicolon there? Okay, then on line 27, so here we need to use it. And for void, we can actually use new list, which creates a new list. So yeah, basically that's nice. We can actually have like second item and then a new list, and just stop that. What is it, an extra? Yeah. So basically that's one way to do it. And let's try to do another thing. Let's create a class person, and this one will have name, string, and I don't know, like food string, I guess. And then we initialize the person, and let's say that value is an object now. So we've changed the list to be, let's say, more generic. So basically, instead of just printing here, let's see if nice. We should use a case. Okay, let's see how case looks like, because I have no idea. I just know that it should be possible to. So you pass in the value and then off and then the ending. So then we have x. If x is person, then we have to print let's put an equal or something. If x is string, then we just print a string, and if x is object, if it's any other object, then we can do something like abort, and then, well, yeah, we should rather have let v equals like this, and then we should output the string. So this should work as usual. Line 40. Yeah, I always forget to put the semicolons when 28. Oh, because we didn't use in statement. So basically this should move a bit. And let's say let's use an in statement and like that or something. Yeah, I don't know. Like this, it looks fine. Still on this line, there's like an issue. Oh, we have to specify the type, right? Yeah, I think like each time you declare a variable, you have to put a type. I don't think it's negotiable. Okay, that's interesting. Syntax error. Do we need like no, it's expression. Do we really need those? First, let's remove it. Yeah, it looks like you need that. $28. Well, that's a bit strange because new list should be void, so I'm not sure we call to this one. maybe let's put maybe let's try to have like void, which is gonna be a list, and let's make it a new list like this. Let's see if this changes anything. We need a comma there. It still does that, so not sure what it wants. Oh, maybe not use the new thing, because that creates, yeah, that creates an object. Okay, so yeah, whatever. Let's have here person again. Let's see if it works to access the person's name. So this is syntax error. Do we really need something like this? Do we need maybe a print statement? And then this should inherit IO again. So, but not really, because I would like to have just a string here. So this should be like show. So name concat likes to it, whatever. So then can we do like x show? Man. Oh, but yeah, we don't need to first. Oh, now it works. Let's create guy. John likes to eat pizza. And instead of second, let's put guy. Oh, that's really cool. So we actually got a list with random stuff inside of it. So yeah, let's keep this example. And like at the end, when the compiler is done, we'll try to run this example with our compiler or something like that. I mean, it's not really a complicated one. I've seen ones that are pretty weird, but yeah, I mean, it's decent, I guess. So yeah, basically now for for the tokenizer, right? So we have all this stuff which are like, they describe how each feature works in the language. So we can go through them. I already did some, like a bit of looking through it, already know some stuff, so not really gonna go through them. Like the most important thing is that you need a main class, and you have like these basic classes for stuff, but that's more like when you actually have a compiler, right? Like these are not really relevant at the beginning, not even typing method or expressions. Like even the expressions are not important right now. Like the thing that we care about is the lexical structure and maybe a bit about syntax, but not even that. Mostly we just need the tokens. So let's go to the lexical structure. So yeah, basically the tokens from this language are like integers, strings, comments which we will ignore, the keywords, and also white spaces are ignored. So yeah, for numbers, all the numbers are like positive in this language. We don't have negative numbers. To have negative numbers, you have to use I think it's one of the arithmetic operators. This thing, the tilde, that allows you to make a number negative. So all the numbers that we are going to read from a file when we do the tokenization will be like integers, and yeah, that's easy, basically what I'm trying to say. Then for the identifiers, these are also interesting. They are like in C basically, but the only difference is that they have to start with a lowercase. For example, for self, right, it starts with a lowercase. It's an identifier, right? Yeah. So in the example from here, like void is an identifier guy, L, right? Yeah, after that you can actually have like uppercase letters and underscores and stuff. So yeah, that's for identifiers. Then for type, like classes, they have to begin with an uppercase, but then it doesn't matter what's after that. And yeah, here is like the example with self and self type. So they are like an attribute or an identifier and the class type. And then there are like symbols, parentheses, assignments, so on. So that's in this figure for the like one character almost stuff. We also have like this, which is ugly, but yeah, like this is gonna be interesting because we have a sign which is smaller minus, and then we have less than equal. So we're gonna see how we are gonna differentiate between them. Oh yeah, and what's the weirdest thing is that equal, like we are used to two equal signs, but here it's only one. And we also have this equal, greater than for case. So yeah, we're gonna see how we're gonna parse that. Then we have strings, which are like really complicated. To be honest, I would leave them like in their own separate section because they can be like escaped. They have a lot of weird characters and rules like for errors. So let's leave them out. We're gonna use strings obviously, but and like the same for comments, because we can have like nested comments which are like they really suck. So leave them out. Like they'll be in the same boat with strings, I guess. And then we have all the keywords, which is nice because we can just copy paste. Yes, copy paste them. And yeah, like everything is case insensitive. That's I mean, does it really matter? We're gonna, what we can do is do like two lowercase or something when we check for keywords. But yeah, well, keywords are case insensitive, but these two are not case insensitive, so they are case sensitive. I mean, it's such a weird wording, but anyway, false is a type. Yeah, I mean, anyway, we'll just go for case sensitive everywhere. So let's not go into that. Then for white space is like pretty standard, I guess. Anyway, we are gonna skip them. And yeah, after that is like syntax. So yeah, let's start with this thing. So basically what I was thinking was to use the ds.h in this one. So let's into src, and basically ds.h is just a bunch of like helper methods, right? So I mean, we have the queue, but I also added like string builder and slices. But anyway, let's start with the main function. I guess hopefully, yeah, we get the stuff. So I mean, the first thing would be also to add arguments, right? I was thinking to have like command line arguments, so that we can take from parse. And yeah, basically argparse is like argparse from Python. Yeah. So let's first define argparse implementation, and let's take this. Here we need argc and argv, and let's say struct argparse parser is the parser, and we are gonna do argparse new. Wait, the new function. Oh, so it's actually like this. So it has to be, yeah. And we need to pass like the name, description, and version. So name is cool C, cool compiler, whatever. After that, we have to add argument, and let me check the checker because I put here like, well, it's like a flag. oh yeah, you pass like a flag. So Lexer will be flag. So let's say L Lexer. I don't remember the arguments, to be honest. Oh, so it's, yeah, I changed it. So it takes in now the rparse options. Yeah, so I think its short name, it's gonna be L. Long name, I already said Lexer, so. But yeah, it makes sense to be Lex. Run the, well, really buggy. So we have description, type, and required. So description, select the input file. Then the type should be I don't remember the type, so it should be a flag. So it should be a flag, and then required should be set to 0. So required is 0. Okay. Then inside of checker, I was thinking to have the input to be positional. Okay, so but I just realized that, well, it doesn't matter. So we are gonna need our parse input type is gonna be positional, required should be 1, so this should be the input file. And pretty much that's it. So our parse, and we should have the things. So basically now if we remake it and try to use help, it shows us the stuff. So yeah, now we need assigned int lex, pretty good. And if lex is equal to 1, then we have to, well, first let's do a char pointer input. Yeah, and here we just do get value. And we should read the file. So let's again copy, but this time an example. Wait, don't we have examples? Oh, in DS we have examples. Because I have a good example of reading files, put it in src, and basically let's see, we just need to copy this stuff, I think. Yeah, we could just copy paste this. Into the main function, or like into the main file. So define this. Let's use everything. I mean, we can put like SB because we need a string builder. But yeah, basically this reads a file into the buffer. And I mean, if you don't provide a file, it reads from standard input, but we are not gonna need that functionality. So let's do char pointer buffer, and then we let's also use the defer thingy. So here we defer and we free the parser. So here we return defer1. Yeah, just like this. So now inside of buffer we have some stuff. So here if buffer, then we free it. And inside of Lex, I think we should do something like yeah, not sure yet. But we can just do Lexer and give it a buffer. So I think that's a decent approach for now. And yeah, I mean for now we're just gonna print tokens. So yeah, let's create Lexer. That's gonna take the buffer, and pretty much if we rebuild everything, we don't need read C. I mean, we could keep like a separate file for reading, but not sure about it. Yeah. Anyway, for now I think it's fine. So let's remove that and let's go with tests and try to parse to Lex this one. So we need to Lex. And at first it will just print the entire buffer. So yeah, now we need to actually do it. And if you remember, we already did something similar for the ini parser. So I would say maybe let's call this one run Lexer. Just so we can create a structure. So we are gonna need a structure Lexer. That's gonna take the pointer to the buffer, unsigned int read position is gonna have unsigned int position and the character ch. Basically, like this pattern is from the interpreter book, I think. So Yeah, but I mean, if it works, it works basically. So yeah. Yeah, I was just thinking that maybe we want a separate file for the Lexer, the Lexer.h or something. Let's do something like that. And here let's include the Lexer, and in main we also include Lexer. So let's copy this stuff into here and then to the other one. So pretty much we can do this for now and this. So I'm thinking that maybe we can just try to copy paste from the other one, because I mean we already have it, so why not? So yeah, I mean we are also gonna have token types, and this was just for printing the token. Then for letters, so yeah, I mean why not just copy pasting this. Let's put it here. So these are the utils. This checks if we have a letter, so AZ. Although it should be more like is lower letter, like this, is upper letter like this, then is digit, it's fine, then is valid char should be, although I would say more like is valid like word is word char maybe. Wait, just a quick question about the identifiers. Oh, they can have digits, perfect. Letters, digit, and underscores. And I guess classes too, so. So is word char basically. Okay. Then we're gonna have is space. I don't think we need is just space. We're gonna need white space to skip it. So basically these are the character utils. Anyway, I was thinking to write a comment, but pretty simple stuff. Okay, so the next thing would be, like I said, to have the token types. So let's do maybe above the enum token type, and let's do, actually let's try to make like each test work, right? So we're gonna need class, like for token types, yeah, maybe let's start with illegal token. But then the interesting thing would be, we need like the names, class, right? Just class, left brace, let's see, L brace, right brace, then we have semicolons, we also have inherits, I was thinking let's sort these, or not sort them, that's a good question. But we also need like something called class name, probably, just for the value itself, right? So class name, like class will represent the class keyword and class name will represent the token itself. Yeah, I know. I was just thinking that maybe having them sorted alphabetically. Yeah, anyway, doesn't matter. Okay, the next thing would be to have the token, actually. So let's do struct token. It will have the type, and we can also include here the literal. Like for example, I was thinking maybe I can try to do it in Rust, just because the enums can have here like the string. But then I was thinking, well, yeah, I mean, does it really matter? Like we can put it here and it's like the same thing, maybe even a bit easier. But yeah, anyway, like it works. It's we can also try to do it in multiple languages or something. That could be fun, although I think it takes like a lot of time to finish the compiler, so by the time we are done with C, probably we are not gonna be in the mood for part 2. Yeah. Although, yeah, I mean, in some weird way, like this feels like the more interesting part of programming, like the compiler stuff. So that's that would be interesting to try out. So we have all this stuff. Anyway, for error handling, but we are not at error handling though. So let's continue. Basically, oh yeah, and we can also say like static for all these functions, because they are used only inside this file. Right. They are not gonna be used outside. So let's continue. with lexer init, read char, pick char, and stuff. These functions could also be static here. Okay. And I was thinking like maybe the lexer should return like a list of tokens. Would it make sense? Or something like that? I mean, we could also use the DA stuff for it, so but anyway, we can also keep here the line and column, but that's for when we get to error handling. So some other helpers, right? Skip white space. Again, we can just copy paste it because it's from the other project we did. So basically, if we encounter white space, we just skip it with read char. So like this initializes the lexer, this moves the lexer forward and changes the current character. This just gives us the current character, doesn't move the lexer. It's more like a way to access this field without really accessing it, you know. And this thing should always return like a token. So this kind of structure with some type. Oh, obviously, yeah. We also need like an end token, end of file, let's call it. So basically, if you keep calling next token, you are gonna get end of file tokens. That's pretty much the idea. Then this was just for ini files. Skip line. Yeah, something for error handling would be good, but not yet. So let's start with the implementation. So it has a buffer. Let's call this one buffer or something. And I like to keep it buffer. We read one character, then how I implemented here the read character is first we pick the lexer, and basically we set the character to that value. Then the position is the old read position, and we advance the read position forward. So like the next time we read, we get the next character. But like this, lpos is basically the position of this character, right? So that's how I'm thinking to keep the line and column. We could try to use lpos inside of the token. Maybe that's one way, or the other way is each time we encounter a new line, we increase the number of line, like the line number, and we just reset the column. But I guess this could work. I don't see why not. Then for pick, we just look at the read position. So let's paste this one. Basically, we look at the character. I was just thinking, what if we just pre-compute this thing? So let's have here the signed int bufferlen, because we are gonna need string.h. Or I mean, let's not depend on string.h. Let's just say that lexer init also takes in the buffer length. Like, that's fair enough. Okay, so here we can just compare with buffer length. And we return the 0 character. And here we just take the current character. Okay. So now the last thing we need to do is next token. I'm curious what I did here. Yeah, I mean, next token is pretty much specific to I made these static. Not sure if you need to specify static each time you write a function, but anyway. So first thing we need to do in next token is to read the current character. So basically, well, I lied. It's to skip the white spaces. So pretty obvious move. We skip the white spaces. And yeah, basically if the current character is 0 or like null, then we have to, well, we could do a switch statement on the current character. Like this makes sense. So we have a case. If we find 0, would it make more sense? Yeah, I think here we should return it like this to make it more obvious. Okay, so if we find a 0, then we have to return something like this. Yeah, sure. So we need stdlib for null. Like, then maybe here we can just use strlen. So let's include string and let's just keep it simple. So that's the first case. Then the next case, well, in our case, I guess, is let's have curly brace. Well, the literal could also be null because we don't care about it. Air brace and semicolon. Like, these are the the simple ones. Right. And let's do a default, and default will be return illegal. For literal, like, it might make sense to put a character there or something, but yeah, whatever. Like I said, maybe we want to have the line number and the column number, but for now we don't really care about illegal. So yeah. Oh yeah, no, the thing why like switch doesn't really work is because how are we gonna that's so stupid. Might be easier to do it if else, you know. So if it's equal to this thing, then if else okay. Well, could also have like else if, just to make it a bit tighter. Pretty much the same thing as before. But now if we find a lowercase letter, then we have to read while we find lowercase letters. So let's put here to do read identifier or keyword basically. Then else if is upper letter, read class name basically, and in the else case it's an illegal token. Well, yeah, it doesn't return here. So reading the class name is pretty simple because we already know, like, it's really similar also to this one, string view. Oh, that's how I was doing the, yeah, that's a nice touch there, but we are gonna do it when we have errors. Yeah, we could try to use the string view. Yeah, why not? So yeah, the only thing that I was thinking about is that, well, since this is like a header only library, if we define it in multiple places, this thing is not gonna work. So we should define everything as static basically. And the other option would be to expose the type of the structure, which would make it a bit meh, my opinion. Wait, let's see how I free the stuff. So like maybe another thing I can do is to have an alloc function or something. Although yeah, that doesn't make sense. Like the easiest way I think would be to define everything as static. Right, like that's how you would do it? Oh, not sure. Anyway. So like if we include ds.h, right, like doing make should work. Oh, we can't use EOF. We need to use end. Yeah, let's use end. Why not? Oh, I'm doing with W error. That sucks. So let's say return 0 or something. Void buffer just to use it. Let's just do a return there. I just found, really? Let's go into the make file and you know what? Let's put the good ones there. So yeah. So if we go in the main file, here we have SB implementation, right? So now if we go back to lexer.c, what I'm thinking is that if we add this one here, it won't work because it's redefining stuff. So maybe one way is to check the image, how this is done, because it's and this was the inspiration, I guess. So you would have here static, right, and then all the functions are defined with that. So like, do we see something about static? Maybe why this was used? Not really. But yeah, my guess is that if we make everything static, then it should work. Or the other option would be to yeah, like put here the entire structure. Although yeah, my concern for that is that if you want to use this as a header and define your own structure, then that defeats the purpose. So maybe the best thing we can have is like the allocator. Right, like ds purity q maybe another thing. Wait. It's just by looking and I was thinking like maybe like this, like have an alloc function which allocates the data structure. No. And then we don't really need to include any implementation inside of this one. Or yeah, the other option would be to use static, which I like more, to be honest. So let's copy paste this thing, and I think this should go probably somewhere like here or something. Let's have like dsdef, dshdef or something. Yeah, so now we put that thing on everything, right? And even in the implementation, I guess. Wait, it's stb image. So here it begins basically. I mean, this one is so big. Okay, so those are static because they are like local for this, and then still uses that. Okay, so yeah, pretty much we have to. Whoa. Put something. Okay, let's do a macro because it's oh, did what? Anyway, so I guess that's one way to do it. Okay, let's do just to see everything. So this is the init function, should have. I think I like if That's what I'm hoping. I mean, I'm not really sure at all if this will work. But from what I know, if a function is static, then it's like defined only in the current scope, like only in the current file. So it shouldn't interfere with other stuff. So if we go back to main, this is some stuff, Lexer, whatever, and now if we compile this thing, it's fine. Okay, perfect. So if we this implementation, and what if we, oh my god, what if we do the define static? What if we do like this and we run make? It still works. Perfect. So yeah, it means that we can do like static. Well, it should be enough, I think, to define that, right? Because this one is not defined, and yeah. Okay. Yeah. Anyway, let's go into the get next token, and basically we need to read characters. So let's continue with our copy pasting behavior. So we create a literal from the buffer. So why does it complain now? What? Oh, it's a DS string view. Oh, it's string slice in my and it's SS implementation. Yeah. Okay. And we have str and len. So it's str and len. Yeah, I was thinking of the Rust string slices for this one. Okay, so then we need a while loop. Don't I already have a function for this? Like, is word char. So if we find a word character on the current character, basically, we could use pick, but it's easier. We basically increment the length of our literal and we read the next character. And yeah, so I think literal, it's something else, it's to owned, keeping the Rust vibes. Well, what? So this gets, oh, it's something stupid like we have a char pointer literal equals to null. Well, I mean, let's say slice. Literal, and here we do slice and that thing, and here we initialize with the literal. Perfect. So this is for the class name basically, because we know that since it's an uppercase, the only thing it can be is a class name. Okay, so after that, here we need to read again the same, right? We read the same thing, but instead of creating the token like this, we need some sort of mapping. So return map keyword, not sure how to call it. Keyword in map keyword, whatever. It's weird because it's keyword or identifier. Anyway, map keyword it is. Oof, the hardest problem in computer science is naming stuff. Actually, understandable. So let's see where we can have that. Oh, we only have inherits anyway. So literal to token. Maybe that's a good one. Literal to token. That was like talking to myself like I was talking to someone else. Anyway, so let's put it here. So static struct token literal to token. So if we find class, oh, that's class name, right? So oh, it is class name. Hell. Anyway, so if we find the word class inside of the literal, then we just return class, and this can be null, in my opinion. If, yeah, just like this. Okay, so the other thing is, since this stuff allocates, right? This allocates memory. It means we can actually free. Wait, no. Well, yeah, it allocates. Yeah, it allocates because it's owned. Know what I mean? It's Rust basically. So yeah, like here we could actually free. I guess we can free the literal because yeah, like basically here we create a slice and the slice is just like a view inside of the current buffer. So when we increase the length and stuff, we just increase this value. We like the str is just a pointer to the existing buffer, so we don't allocate anything. And then here we basically create a string from that slice, so we malloc it, right? So yeah, basically here in literal to token we kind of have to free it. We could use ds free though for that. Like yeah, basically we just free the memory. Okay, so we no longer need that there. Perfect. I think that's it for the first test, at least, right? So let's see. Let's create a lexer. Let's initialize it. Well, why would we use a const char? Anyway, we return the lexer and then create a token. And yeah, let's do that function token to string, token type to string. So it should be, well, let me see here. Oh, it's a const char. Okay, perfect. Const char pointer token type to string. Perfect. So then we can do a do while. We take the token and we print it. Okay, so if we make, it won't work on that one, but it should work on the first one. Well, at least that's what I thought. I guess I forgot to do next somewhere. Oh, right. So regardless if we find token or not, we have to advance for everything. Let's see. So peeking, yeah, it should work. Okay, so like the idea is if we find this character, we want to advance one position, and I mean return it, create a token, but we need to advance. Then for the same for air brace, semicolon. I'm not sure about lower letter should read while. so it should stop on a white space, so it's fine. Upper letter the same, and illegal should advance also, right? Like if we find an illegal token, then we advance. Okay, so we find token class name A, Lbrace Airbrace, semicolon, another class with the name B. It has an inherit. That's, dude, it's really cool. Seeing it, semicolon, and the end token. That's really nice. I mean, for the first part, let's say we got something going. So yeah, like the only thing is, how do we define a good, let's say, tokenizer? Should it be just like this thing, just this string, for example, to make the test pass, or should we have something else? What I'm thinking is to have like a class. Let's make a better printing. So we should have printf, then %s, and here we do the class, or I mean the token type. Right, do like that. Then if toc literal, we print it in parentheses, and then we printf a new line. So this is how I'm thinking. Pretty much the Rust way, basically, if you think about it. So class, then class name and the actual name. I think this is how I would like to see the tokens. Yeah. So basically this is the first stage of our tokenizer. Pretty simple, just like really few tokens, like braces, and it's pretty much really easy to extend this thing further. So like I guess I can do it also. I guess I'll do it in the next one, but like I was thinking, the next interesting thing would be, how about the stuff that takes up 2 characters? That would be more interesting to see than the rest of them. Like parentheses is like just copy paste this thing, but I mean that can be done at the end, let's say. Well, I mean, I'll be curious what's the next test, right? So the next test should work too. Yeah. Then the third one. Yeah, so for the next time, I guess we'll look into double length stuff and numbers. So that's what I'm thinking. It's gonna be more interesting in some way. And yeah, basically just try to iterate over the tests. So that's the idea. Okay, so yeah, basically, I mean the checker won't work, but we have found like a way to think about the. Oh, we have an illegal token though in 02. I think it's this one. So yeah, I mean the column anyway, doesn't matter. So we can go into this thing, just add it somewhere. No, then here you just check for column and you get it. But yeah, for next time we are gonna look into the double length ones and basically finish up all the other tokens, and pretty much will be ready for strings, let's say, and comments, and those will be more interesting. And after that, the errors, right? So these are the steps I would like to take for the lecture. So yeah, thank you for your time.